So was it like the CAT scan, MRI?
I think it's one of those two.
Yeah. See, I want to see it all. Okay? If something's going to happen and you're going to send me for a diagnostic test, I want to see. All right? So I tell them ahead of time, you know, before they do anything. I'm like, okay, now look, here's what I teach, here's what I do, and guess what? You're not going to be the only one who gets to look inside my body. All right? If this is going to happen, I want to see it too. Then I had to have knee surgery. It's been about 2 years ago? 3. Oh, wow. Cool. Okay, so I, tell them, and, my doctor, well, this is hard to put up with me real good, and I was like, I want it recorded. And, they don't like to do that, liability and all that type of stuff. But we get ready, I'm at the, getting ready to go into the surgery, and I'm like, got the recorder ready? Oh, no, I don't think. No. We're not going into surgery till you go get the DVR, till you go get the recorder set up. Sure enough, he went and got the lady to go set everything up and recorded my surgery for me. So, okay, so sure enough, he goes in, sets it up, gives me the recording of it and everything. So, it ended up being really cool. I got to see exactly what he did to my knee. Now, when I have a family member go for stuff, I'm like, ask your doctor if they'll record it. Ask them if they'll record it, I don't think they do that. But anyway, some of the imaging techniques, a lot of these you've already probably heard of. Radiography, ultrasound, the CAT scan, dynamic spatial reconstruction, alrighty then, digital subtraction angiography, magnetic resonance imaging, MRI, PET scan. Y'all know anybody who's ever had a PET scan? The reason why I ask, PET scans are a last resort. They send you for a PET scan, it's bad. All right? Chances are death is around the corner. All right? But the way that a PET scan works is so cool. The way that a PET scan works, we all know that we need glucose, right? All right? Glucose is the smallest molecule that the body uses. And I mean, it uses it quick, okay? They have basically taken a glucose molecule that has been irradiated and they follow it through the parts of the body. That is the coolest thing ever. I just want to go have one just to see what's going on. But they don't normally do that unless I got to pay for it out of pocket. But hey. So x-rays, those of course were the first. Still good, okay? Even though basically we just saw, the bones, but that was very beneficial at the time that they came out. And the lady who did the original discovery for x-rays, because we didn't know all of the effects of getting this x-ray exposure. She, of course, died, and that sort of thing. Didn't get all the credit she should have gotten. Ultrasound, truly now, the 4D, the first true picture of your baby. Ultrasounds, however, they utilize ultrasound for way more than just pregnancy, okay? I don't think, is there a single organ that can't ultrasound?
I know, I have one, and it was just for, like cysts they don't have cysts, so they were able to do like, but it's like a different kind of ultrasound, like, you know.
It's not the one they rub, it's one they
like,
insert.
Yeah, and like they showed me the thing, and it like you're able to see like all of it inside, like,
and then
they like video it.
They can like ultrasound the heart, the lungs, the abdominal cavity. I don't know if they do anything with the head, but you know what I'm saying, right? Okay, they do just about everything for ultrasound. Now, the CT scans, those get a little more detailed because they're going to give us a little more picture, a little better view of the softer tissues of the body. Not only do we get to see the bone structure, but we're also getting a view of the soft tissues. Okay, depending on whether they may have injected you with a dye or not, okay, determines how much we actually get to see. Now, this right here, I am not familiar with at all, okay? This 3D stuff, okay, I just haven't got into yet. All right, so I'm trying to stay away from it for as long as I can. Now, the angiography. The really cool thing about the angiography, it's showing you the blood flow. All right, so it's very specialized, and they can do it to the certain parts of the body and actually see the blood flow. And that, of course, becomes beneficial at a time of like a clot, aneurysm, that sort of thing. The MRIs, oh, I had so much fun looking at the MRIs, you know, that I had done on my knee. And I like to get it and just go through the pictures really quick, and it looks like the little cartoon things that they used to do to make cartoons, okay? Because you get to go to see big to small, small to big, and that sort of thing. So it was really kind of cool. But MRI is that magnetic resonance, all right? So if anybody has like any type of metal in their body, this is not something they want to do, okay? And if they do have metal in their body, you put them in that MRI and you don't know it, guess what? That metal's coming out of wherever it might be, all right? That's how strong the magnets are in these machines. But the cool thing about it, gives us very detailed information, not only about hard tissue, osseous tissue, but soft tissue also. So MRI is a little more extensive than the CAT scan. The PET scan, things light up, okay? They glow like fireworks. The people who, of course, are doing this, they'll know what the red, the orange, the blue, the green is supposed to mean. But whatever's lighting up is due to that radioactive glucose, which is so cool. I think it is anyway. So all of these techniques have helped us understand what we're going to be moving into for the rest of this course. And of course, what you're going to be running into for your programs. Now, what we're going to start with, we're going to start in Chapter 2, and that's actually starting us at that lowest level. Do you guys remember the levels of organization from yesterday? And what we're going to start with, we're going to start at this chemical part of life. When I was in college, it was like, oh, biology is more important. Chemistry is more important. Biology, chemistry, biology, chemistry. So I decided to check it out. All right. Ended up actually getting the minor in chemistry, and I will tell you this, nothing exists without chemistry. Nothing. Nothing. Zip, zilch, nada. Okay? Everybody know the periodic table. Familiar with it, seen it. Okay? It has a really cool structure to it. Not sure if you guys remember the structure. What does this number? All right, where you've got what they consider the left versus the right, where over here we've got metals, over here we've got gases, over here the transitional metals. Does everybody kind of remember that? And then of course a bunch of radioactive stuff down here, blah, 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 blah. Okay, bunch of radioactive stuff down there. All right. And, you know, as you look at it, you know, you've got like the number 1, 2, 3, that sort of thing, lots of information, okay? Nothing. Please listen to what I'm saying, because you've got to understand this portion to be able to understand that plasma membrane, okay? Nothing exists without the activity of electrons. Do you remember those? Okay? Did you take chemistry? Okay? It's okay, because I'm going to catch you up on what you need to know. All right? But the chemical basis of life, hey, chemistry's life. Life is chemistry. There's no other way to put it. Our purposes, we're going to keep it on a simplified level, okay? When we look at the basics of chemistry, we look at matter, mass, weight, and that's going to give us information that becomes important for elements and atoms. Matter, anything occupies space. Mass, what's the weight? Weight, what's that gravitational force acting on it? On Earth, we've got a lot of gravitation, a lot of gravity. Okay, wears us down every single day. If I could go to another planet, I wouldn't weigh as much. Might go to a planet where I weigh more. But that's not the planet I want to go to. Just saying. Now, on Earth, gravity, okay, is heavy. When we begin to look at how we can actually form this desk, form the clothes we're wearing, form us, form the molecules, the cells, everything that's making us up, okay? We've got to deal with these. An element, what is that? Give me an example of one. Hydrogen. Carbon. Nitrogen. Oxygen. Everything that's on the table. We're going to look at the ones, of course, that are going to deal with us. Some we're exposed to, some we need. But the element, what is the simplest form of that? Atoms, the smallest particle that retains the properties. Carbon. Why don't I choose carbon? We consider that to be the organic molecule. We consider it to be the molecule of life. All right? On the periodic table, it's number 6, has a mass of 12. That's going to become very important, especially to what we know as life. Okay? When we look at these atoms, these elements, all right, the elements have what we say is an atomic structure. What is that telling me? That's telling me that the information that I look at on the periodic table is telling me what I need to know about the structure of that element I'm looking at. We have these subatomic particles, neutrons, protons, electrons, positive, negative, no charge. The nucleus. My nucleus is formed by the protons and the neutrons. It's my electrons that become important. All right? They are going to tell me how this element that I'm looking at is going to act or react. So if I look at this carbon, let's look at this one. This is number 6. That's my atomic number. This is my atomic mass. 6 tells me some type of information. What does it tell me? My protons and so this is telling me my protons and my electrons. I got to do a little bit of math to get that third subatomic particle. I just simply take this number from this number, and it tells me I have 6 neutrons. In the structure that is going to be created, if I go back to the last slide, it tells me my nucleus contains my protons, which I have 6 of, and my neutrons. What have I not addressed? Which subatomic particle has not been addressed? My electrons. Now, the electrons exist in these great big huge these huge fields that are going to be existing around the nucleus of that atom. And there's a rule that lets us know how many electrons can fill one shell. Do you happen to remember any of that? Like in my first shell, how many electrons can exist? Up to 2. Okay? Second shell. How many?
6.
Up to 8. A third shell. Okay.
14, 13, 15, 18, 20, 18.
It can hold 8 or up to 18. 8 represents something called octet rule. Now, what does the octet rule tell me? It tells me if that outer shell has at least 8 electrons, my atom is happy and it's not going to react. If it doesn't have 8 electrons, it is not happy and it wants to combine with something. Is everybody with me? So at this point, if I look at carbon, carbon has 6 protons. In the first shell, I can hold up to 2. How many do I have left over? 6 minus 2. I got 4 electrons, so I need a second shell. And I've got 1, 2, 3, 4. How many should the second shell hold to be happy? 8. It's at 4. This is not a happy atom, okay? This is an atom that reacts very quickly. Now, because we are our organic selves,